It's a follow-up video. Last time we discussed about before and after control chart. Now we are going to do process capability or capability analysis. This is a cool feature in Minitab. Whenever we want to do any improvement and we have to go to separate section. And for example, if we have done in control chart or process capability, again, we have to do it separately to know that the improvement is significant or not, right? Through the hypothesis testing. But before that, and directly you can do it like before and after comparison with nice statistical value, significance value, all that you can do it. So just like last time, what I will do, I will create the random data. So I'll give a topic called yield. This is before, yield after. Now what I will do, just in order to explain better CP, CPK and all that, what I will do, I will just keep it as it is. And I will get another yield, which what I will do after I'll reduce standard deviation by half, right? By 50%, I will reduce the standard deviation. And then another one, I will reduce the standard deviation by 75%, right? Let's see how it goes. So for that, I need a random data. So all I have to do is that I have to go to Calci, random data. I need a normal distribution because yield is a variable data. And now I'm going to pick the random. The 30 data is fine. And I'm going to keep like before, let's say the yield is 95 and then standard deviation is 1. Okay, now I got it. Same, I will come redo. I will do it for other one. Now it is for after. I'll say that there is a 2% improvement. 95 became 97 with the same standard deviation of 1. This is done. And then now what I will do, I will reduce that standard deviation. So now what I will say in column C3, I will say 0.5, 1 to 0.5, I will keep it. Okay, this is done. Another one, what I will say, same, but I will also keep, I will reduce the standard deviation further, just 0.25. So I will say this is 75%. Okay, now I have got all that data. Like I don't need all these many decimals. So what I will do, I will just keep it the format numerical, and I will keep the decimal position as just 2 decimal is, or 1 decimal is more than enough. Okay, so now we have the data ready. Let's proceed. Go to assistant, and since we have taken from normal distribution, and one more time you can double check the normality of the data. For sure it will be normal because we have taken from the normal distribution, but we can quickly check that normality, normal distributions, right? You can go to probability plot, and this is the multiple columns we are talking about it, and you can just select all the values and give okay. So you can see here the statistical value. So all are so P8, that means first is also, we will keep it in parallel so we can check. So this is significant, this is significant, maybe still 45% is significant, 69, 70% is significant, 6.3 is also significant. Great, the data is normal. So I can go ahead and further, I can relaxly do before and after comparison. Let's start. So now what I'm doing it, my data is continuous data. So I'm going to keep capability comparison, right? So are in one column? No, I have kept in 2 column, right? So what I will do, I can compare multiple column also, but I will keep it. So this one before, after, and I will come back and do it later. And subgroup, let's say I'm going to keep it like subgroup. All the 30 reading has been taken in 1 day, example, right? Or 30 days, right? Okay, lower specification, I will keep it. The lower specification in the first example, we have seen 94 to 96 with 1%, 1 standard deviation. Let's see before and after. So, sorry, this is baseline data. Sorry, maybe I will just keep it in 1 column. Baseline data will keep it here, and subgroup size I will say 1. And similarly, I will keep the baseline data here, and this is after. And once again, I will just commonly give that subgroup as 94, sorry, in lower specific 94 to 96 yield percentage. So let's say target is 95, of course. Okay, give okay. So now what I have got is I have got both the chart. So this is great actually. So this is first one. What it says is that percentage out of increase 181 percentage from 32 percentage. So first you see that mean is 94 here, and other one, this is before process. Yeah, before process, this is the mean we are targeting here, and now before process, this is the mean value, and from the standard deviation is not okay. From the mean 94.24 is a before, after is 94 became 97, change is 2.3, right? So 2.3 percentage there is a change, right? And now overall is the standard deviation point of view in and around the more or less is same, and ppk you can see the value here. So 0.33, that means is a 1 sigma, and ppk 0.24, and before and after, right? There is not much any improvement. 32, 3,22,000 is still very very high, right? So still lot many things to improve, because you can see that from the did the mean change? Yes, there is a change in mean. That is significant also. You can see 94 became 90, 95 in figure of speech. 95 became 97. That is excellent. But from the standard deviation standpoint, this has not reduced, right? So it also says that reduction in out of spec, how many thing will go? So 180 percentage is increased. So initially it was processes like that. Now this has gone like that. So this is process is completely shifted from the target. So now what I'm doing it, the same thing, control E. I'm going back to the previous command. Instead of 1, what I'm doing it now is that I will keep after 50% improvement. That means my standard deviation is 0.5, right? Still, I will keep the same target, 94. 95 is a target, upper is 96. Okay, now you can see that there is a shift has happened, and in now both are well within the limit. So mean is 94 to 97. I mean 95 to 97. There is a 2% increase. Standard deviation has reduced by half, right? 0.1. Otherwise 0.99 it became 0.5. That is half is increase. I mean decrease. That is great. PP value you can see here, right? And for the pp value, what I will do, I will keep the tolerance bigger, a little bigger, so we can see. Because lower I'm gonna go with the 94, and upper I'm gonna go with the so maybe we can say 95, 96, 90, 98 we can go, and the target is 95, 96, 97, 98. So I will keep it 96. I've just slightly reduced it. So you can see here, the process was like this. Now it has been shifted towards that. This shift is positive, right? So 87%. It also says that 87% is because slightly I have just because there is an improvement. I have just increased the tolerance to capture the improvement. So before after the process standard deviation was reduced significantly, as you can see here. So 0.99 to -1. That is great, and the mean also significant and is closer to the target. This is absolutely great. Now further what I'm doing it, I'm just giving control E. Instead of this, I will keep the value as 75. Now the yield, I mean the standard deviation is still further it will reduce. We'll see here. This is perfect. This is perfect, right? So you can see here the both mean and standard deviation is perfect, and now we can see that it is pp equal to 0.67, and after is 3.29. This is very very great. It is almost like it is 10 sigma, and because 3 is 9 sigma, and closer to 10 sigma ppk. The opportunity for error is absolutely zero. You can see here, right? Opportunity for error is absolutely zero, This is absolutely 100% reduction in out of spec. This is how we can do it. Let's summarize what we discussed. So what we did, we have taken three scenario. Scenario 1, scenario 2, scenario 3. So what has happened to mean? What happened to standard deviation? And maybe I'll keep that the input here somewhere. Okay. Input. Yeah. Standard deviation. What happened to PPK, PPK? We can see, right? Okay. So scenario 1, what we have done, we have given that the target. We have just given the input as 95 with the tolerance of 1, right? This is what we have given. What the mean we got? We got the mean is significant, right? 95 to 97 we have given, right? So what I will do, 95 to 97. So mean shows significant, but the standard deviation says not significant. Since the standard deviation was not significant, the process is not capable, right? The result what we got, maybe instead of PPPPK, I can directly quote the result. Process is not capable. Okay. Now the next one, what I did, the same value. Okay, we just change the standard deviation we reduced to 0.5. So mean became significant and standard deviation became significant. Process, because process has gone beyond 6 sigma, process is capable. And then the last part, what we did in day 3, further we reduce the standard deviation, and also you remember that we also loosen up the target also, like 94 to 98 we did it, and it becomes super great, significant and significant, and then process is capable. Just a quick recap, I'm just going to Control E, and this is the last one, right? So this is the last one where we concluded that PPK is super high. You can see here, almost that out of spec is 0 and the PPM itself 0. The process is 100% improved. Then we reduce the yield. The standard deviation is 50%. You can see here. So here still there is an improvement, but up to, you can see here 0.99, and there is an improvement. So you can 94, and the mean we can see that there is a 2% improvement, and a standard deviation more or less 50%. There is a standard deviation also improvement, and you can see that PP value. So it's still 2, out of spec is 2, and 27,000 can go wrong, right? Because the standard deviation is very critical part here. And the same thing what I did, I just flipped to normal improvement, right? The conventional improvement, very random, not focusing on yield and all that. I mean, the standard deviations, right? So we didn't get the good result there, right? You can see here. So still there is upper 1,64,000 can go wrong, and 16 is out of Z bench is 0.98. That is 0.98 is 1 sigma, right? So this is one. And what we want to have a process, we wanted to have a process like this, right? So when you have the process like this, your sigma goes very, very high, right? So Z bench itself is long term itself 5. That means we are at 6.5 sigma, right? So this is great, and this is how the process should be. And hope to we always should aim to reduce the standard deviation. That's the main motto we should have, not increasing or loosening the target. So I hope you find it useful. Please do like, share, subscribe my channel. You have a wonderful day ahead.